Hi, we talk about free body diagram. What it is for? It is to figure out all the forces applied to an object. So by drawing every force exerted on an object. So by having this program, by having such a program, a diagram, so you can figure out the total force on an object. Therefore, you figure out its acceleration. So in solving many of the mechanics problem involving Newtonian dynamics, the first step is figure out for every object in interaction, separate them, draw it separately, and figure out the force. Our example here is this one block, and on top of it there's another block. And here is a force applied to the bottom one. And also the whole thing is set on the floor. So I think you have seen this type of arrangement very often. You know, like a kid sitting on a car or some slide and carry a box on top of it and so on. And this is a model for those kind of the system. So now, in this case, so object A, okay, you separately draw a box represent the object, and then figure out the forces on this. In this case, gravity goes this way. All right, down, mass times acceleration. At the same time, there is a force from B, from the bottom, up, supporting force from the base box, which is this one. And since the box is not moving in vertical direction, neither up or down, so this force must be equal in the magnitude, but opposite in the direction. And there's another force. Okay, if the object is moving, so there's the force between these two interfaces is provided by the surface friction. So this is the force box B on box A in the horizontal direction. So think about it. Overall, if you add these three vectors, you will see that these two cancels. Overall, it is this friction vector that moves the box forward from the bottom. Now let's take a look at this object, the one on the bottom. It is a little bit more complicated. First of all, there is B, there's a gravity on this box, usually exerted at the center of this. Down, mass mg. Of course, here is the external force. I'm drawing down here. External force is an applied force normally. Now, then there is a force from the top, the pressing force, box A or pressing box B, because that's exactly the opposite force of the box B supporting box A. So these are the Newton's third law pair, action and reaction. So box B supporting B or normal force up, and then box A pressing B down. So this is the force, and then this force is pressing from A to B. So these two are equal and opposite direction, but applied to different objects. And so now, since this box is not normally moving in vertical direction, they are not moving in vertical direction, therefore the acceleration in this vertical direction must be 0. And so there are two applied downwards, gravity downward, and also the boxes on the top pressing it. So there are two downward force. Therefore, there must be same amount of force that pushing upward. All that is supported from the ground. So there's a supporting force from the ground pushing the box up, but not pushing up, but exactly cancel this gravity and the force from the box. So this is the ground to B. So this segment is this segment, and that part cancels this part. So ground will support both of the weight, basically. The ground supporting this long force. So in vertical direction, it is not moving. So this is pressing, this is gravity, but the supporting force from the ground up is this entire force, making this steady in the vertical direction. Now, let's take a look at the horizontal direction. Of course, there's applied force this way, but then there are frictions. And first, the friction on the ground. So if you move the box this to the left, and then the friction from the ground to this is this. So try to resist the motion. So that friction on the B. And also, there is another force which is exactly opposite of the friction the box provide to the upper box. So this friction over here, the friction to the right, and B on A, and then there's a friction from A to B. These two goes in pairs. So this and that. So this is all the forces on the bottom object. So once again, why do we need the free body diagram? The reason is that we want to see how the object will accelerate, because the acceleration depends on the forces, not just on single force, but it depends on all the forces acting together. In other words, the resultant force. We're adding all these forces together, you will figure out which way, at what acceleration, this box will move or will stay. Same as the upper object. Hope this is interesting to you. Okay, if I ask you a question like this, similar situation, this is the starting point. Bye bye for now.